So in this video, we are going to discuss a solid state question, right, which is a previous year question which was asked in your IIT JEE, right? And this is a very important question, right? Because time and again question is keep coming in exams, right? Where be it your IIT JEE, be it your NEET, be it your any higher level exam also, this type of question generally comes, right? So now let's try and solve this question, right? Let's try to read the question once, right? Okay. Element B forms CCP structure and A occupies half of the octahedral voids, while oxygen atom occupy all the tetrahedral voids. The structure of bimetallic oxide is, right? So here it has been given to us that B is forming a CCP structure, right? And A occupies half of the octahedral voids, while oxygen atom occupy all the tetrahedral voids, right? So we have to determine the structure of bimetallic oxide, right? And these were the options given for this question, right? Let's try and try to solve this type of question, right? Okay, so before moving ahead, right, and we'll start solving the question, right, let us try to understand the lattice arrangement of the unit cell, right? So generally what happens in cubic close arrangement, right, whenever the packing is your cubic close, right, so the number of lattice positions available or the number of atoms which can occupy the space is n, right? So number of lattice positions available is your n, right? So if the number of lattice positions available is your n, then the number of octahedral voids formed is also n, and the number of tetrahedral voids formed is 2n, right? So this point you have to remember, right? Not for this question, generally this point helps us solving a lot of questions, right? So if your lattice positions is n, in case I'm talking about only cubic close arrangement, right? So if your lattice position is n, the number of octahedral voids is n, and the number of your tetrahedral voids is 2n, right? All right. Okay, now let's try to solve the question, right? So I'm going to solve this question with two methods, right? Whichever method resonates you can solve that question in that method, right? So in this video we'll be solving the question with both the methods, right? Okay, so let's try now. Let's try to solve the question using first method, right? So this is your first method. Okay, so it's the position given, right? It's the position given, right? Okay, so it's been mentioned in the question only that B is making your CCP packing, right? So the number of available lattice points will be n, right? We understood just now in the previous slide that the number of available lattice points would be your n, right? And A is occupying your half of the tetrahedral voids, right? So it's been mentioned, right? A is occupying half of your octahedral voids, right? So A is occupying a half of your octahedral voids, right? So the number of octahedral voids is n, right? If the lattice points is n, the number of octahedral voids would also be your n. Okay, so now if the octahedral voids is n, so the number of octahedral voids being occupied by A is half the number, right? So number of octahedral voids are total number of octahedral voids divided by your 2 is n by 2. So the total number of lattice points occupied by A is your n by 2, right? And the total number of lattice points occupied by O, that is your oxygen atom, is 2n. Why it's 2n? Because the oxygen atom is occupying all the tetrahedral voids, right? So oxygen atom is occupying all the tetrahedral voids. So the total number of oxygen atoms here is 2n, right? So if we arrange the structure in this manner, right, like A, B and O, because this metal and there's a rule in chemistry, right, that positive charge thing always comes prior to your or negative charge thing, right? So a positive charge thing always come prior to your negative charge thing, right? So A and B are working as your metals and oxygen here is anion, right? So AB comes first before your oxygen. Okay, so the total number of A type of atoms is here n by 2. As you can see, the total number of A atoms is n by 2, and we found just now that total number of B type of atom is here n, right? And the total number of oxygen is 2n, right? So if we take n as common, right, so A half B1 O2 would be a structure, right? Now we don't want to leave the structure in fractions, right? We want the structure to be simplified, right? So what we'll do, we'll multiply the structure with 2, right? So that fraction fraction numeric would be removed, right? So if we multiply this number by by 2, so the structure would be, right, Ab2O4, right? If you multiply this number by 2, you can see the structure would be Ab2O4, right? So the simplest structure of bimetallic oxide we got is your Ab24. All right. So this is the way we can solve this type of question using your method 1, right? Now there's another way in which you can solve this question. Let's try to figure out that method now. Okay, all right. So this is your method 2, right, in which you can solve this question. All right. So this is your lattice position again giving, right? So B is making your CCP packing. As you can see, B is making your CCP packing, right? B is making your CCP packing. All right. So if B is making your CCP packing, right? So in those questions, right? Please listen carefully, right? In those questions, wherever it's mentioned that this so and so metal or this so and so anion is making your CCP packing, and it's not mentioned whether it's your FCC packing, it's your HCP packing, or any other packing, right? Then as a default, right? Then as a default, you have to take that packing to be FCC only, right? It's a default thing, right? If it's not mentioned, it's only if only CCP term is mentioned, right? Then by default you have to take the packing to be CCP only, right? FCC only, right? Face centered cubic close packing, right? So if B is making your CCP packing, so it's FCC kind of a packing, right? So the number of lattice points of B would be 4, because we know that total number of atoms occupying in FCC kind of a lattice is 4, right? So A is occupying half of your octahedral voids. If your lattice points is 4, so octahedral voids would also be 4, and it's occupying half of the position, so the total number of octahedral voids would be 2. Quite simple, no? It's quite mathematical, nothing else, right? Okay, and oxygen is occupying your all tetrahedral voids, right? So if N is your packing, right, so total number of octahedral voids will be N again, and the total number of tetrahedral voids would be 2N. So if N is your 4, so total number of tetrahedral voids would be your 8, right? So the structure representation for your bimetallic compound would be A2, because total number of A atoms we found out 2, total number of B atoms are 4, and total number of your oxygen atoms is 8, right? So if we take 2 as common, because we want the structure to be a simplest form, right? If we take 2 as common, the structure would be A1B2O4, or we can say AB2O4, right? So the simplest structure of bimetallic oxide is your AB2O4. Here 2 metals are used, that's why it's called bimetallic oxide, right? So these type of question time and again keep coming in your various type of exams, right? So you cannot afford to miss these type of questions, right? Okay, so if you found out this video useful, right, if you find this video useful, give it a big thumbs up, and please subscribe to my channel, right? And do mention me in the comment section if you want some specific video, right? I'll be glad to help you guys, right? Okay, all right, thank you so much.